Hi, guys. I'm sure by now you've heard the news that we won't be meeting in person again, so I'll keep up the videos. Hopefully, if you're anything like me, it's nice to just see a friendly face, or a familiar face, I should say. So we are going to be working with our volume of pyramids today. This week is actually, we'll finish up pyramids today, and then we'll talk about cones on Wednesday and spheres on Friday, and that'll kind of wrap up this chapter. So next week we'll probably throw a review together for you, maybe do a Zoom meeting to kind of clean up any last little um, confusion over the topic before we move on to our last chapter, which would be dealing with properties of circles. So with that being said, just want you guys to all to know that I miss you a lot, and I'm really looking forward to seeing everybody next year. So, all right, let's go ahead and get started. So, looking at the two pyramids here, we can see that they are both both have the same base area and the same height. They both fit into the same rectangular prism. So we can see here the base on each of them is exactly the same. And the pyramid here on the left is called a right pyramid, and that's because it forms a right angle. The height makes a right angle with the base. So if we were to draw the height straight down, and it lands in the center of the base. So right pyramids are pretty handy, especially we've used them quite a bit with our slant height, with our surface area, because they're easier to calculate. The other pyramid we have here is called an oblique pyramid. And that is because, wow, I did a really bad job tracing those lines out. Let's try that again. That's because the apex, or the top of it, is not directly in line with the center of the base. So if I was to draw the height down, we could see it really kind of comes in more so on the right side of the pyramid as opposed to the center of the base like the other one. So it's off quite a bit. One thing that we note, the reason we look at these is because if they have the same base area and the same height, they will also have the same volume. Just like we talked about with parallelograms, just like you see with triangles, the same information happens with pyramids. So looking here, we can see if we draw diagonals in a cube. So remember, a cube, all of the faces of a cube are exactly the same. So they're equal in area. So all of these pyramids then, because they're drawn from a cube, will have the same base area in each of the pyramids. So same base area, same height as well, because distance from one side of the pyramid is the same in all situations. So they have the same base area and the same height. So all three of these have the same volume. And since we know how to find the volume of a cube, that means we can also find the volume of the pyramid as well. So just to kind of illustrate that even a little bit more so, I have a cool little video here to show you. We would have done this in class too, and I'll speed this along just a little bit as soon as I can get the video to come up. And it's got some great music. Oh, let's see if it'll, oops. Oh man, I messed it up. There we go. Oh, okay. Is it working? There we go. So they're showing here that we have these pyramid and cube that are the same. Same base area, same height, you can see there. And so what he's going to do is he's going to fill this pyramid. We want to figure out how many times it takes. If he fills that pyramid up and empties it into the cube, how many fills it will take. So there's one. And then he's going to fill another pyramid, same base area, same height. So there's two. And lastly, you can see it's getting close to the top, and if he fills this up, he's got it kind of tilting a little bit. There we go. Not quite full, but it's close enough that we can get an idea of what's going on here. And we can see, boom, there we go. So in this situation, it takes 3 pyramids to fill a cube with the same base area and the same height. So that helps us then to see the volume of a pyramid is going to be the same as the volume of a prism, so base area times height. And then because it takes 3 pyramids to fit into the prism, we can just divide our answer by 3. So using that, let's do a couple of quick examples here. So we need to know what's the base area of this prism. Well, the base is a rectangle now, so it's 5 by 4. So our base area would be 20. And our height of the prism, very clearly we can see there, is 6. So to find our volume, we're just going to do 20, the base area, times 6 divided by 3. And 20 times 6 is 120, and divided by 3, is going to give you 40 feet cubed. And that's all there is to it. You just need to know what's the base area and what's the height. So on our part B, our base is now a triangle. So we need to know the area of that base. So 7 times 6, but it's a triangle, so we got to cut that in half. So that's 42 divided by 2. That gives us a base area of 21. And the height is 8. So then our volume will be our base area of 21 times the height of the pyramid divided by 3. And 21 times 8, I don't have that calculation. I just had the final answer, and that's going to be 56 meters cubed. And then one more here real quick. This one's kind of drawn funny. They gave us the width of this is 8 meters on that rectangular base, but they don't give us the front edge. They give us inside is 6.6 meters, which means the other part of this has to be, we're assuming that the height is drawn to the center. It doesn't say it's an oblique pyramid. So the other half would also be 6.6, which means that the entire edge of this is going to be 13.2. And so then if we need to know the base area, we want, let's see here, I'm going to write this up here. The base area would be 8 times 13.2, which would be 105.6. And then we can clearly see our height is 11. So now to find our volume, we're going to do 105.6 times 11 divided by 3, because 3 pyramids fit into the same area as that rectangular prism would be. And that's going to give us, and I just have the final calculation here, this would be 387.2 meters cubed. So that's kind of the short, quick version of it. I've got one more video. I'm going to come back and show you some information about what if we don't have the height or if we don't have a measurement. So how could we find the rest of this? So if you're needing help on that, come on back and we'll go through that in just a minute.